In the past video, I talked a bit about how we went from a cosmology based on myths to one based on scientific inquiry. Now let's take a look at what we know about the universe as of now. We talked about how we came to the conception of a spherical Earth. In fact, the Earth is now known to be an oblate spheroid. The pole-to-pole diameter is about 40 kilometers shorter than the equatorial diameter, meaning there's a bulge in the middle. This stems from the molten interior of the Earth and the fact that the Earth is not a homogeneous solid. We also talked about the heliocentric solar system, with the Earth moving around the Sun at a speed of about 107,000 kilometers per hour. Now, from ancient times, we could observe many stars in the sky. With three rare exceptions, the lights and stars we can see in our night sky with our unaided eyes all belong to the Milky Way. Despite being inside the Milky Way galaxy, owing to the stars we see in our sky and their pattern of motion, we have been able to decipher the shape of our galaxy and the motion of these stars. At the start, going from geocentrism to heliocentrism conveyed that the Sun is now the center of the universe. Yet later we found out that the Sun, and the solar system as a whole, is itself moving relative to the other stars in the Milky Way. The Milky Way is a barred spiral galaxy, a galaxy which has arms rotating around the central bulge. The solar system is moving around this central bulge at a speed of 828,000 kilometers per hour, and it takes about 230 million years for one full rotation. To study the rest of the universe, we had to rely on invisible parts of the electromagnetic spectra. Parts of these electromagnetic waves can make it to the surface of the Earth, while for others we have to send space telescopes to space. The most famous space telescope is the Hubble Space Telescope, launched in 1990 and is still in operation. It has multiple instruments sensitive to different types of electromagnetic radiation. Many other such space observatories are also in orbit nowadays and are complemented by ground-based radio telescopes. Using these tools, we can look for features in the electromagnetic waves we receive from different locations in the night sky and identify objects such as galaxies, black holes, and other features in the night sky. What is also notable is that when using these tools, due to the fact that the distances are so large and electromagnetic waves propel at a fixed speed, which is the speed of light, it is as if we are looking into the past. The further we look, the more we see the past features that used to be in that location when the light emanated from that location. As such, we can only study the evolution of objects by looking at similar objects at different distances to us. But we are limited by the size of the observable universe, the area of the universe that light from it has had enough time to reach us. We will never be able to see parts of the universe as we move further away from them, and that's something that we have to deal with. Using these tools, though, we were able to look back and back to the farthest points we can see. Through these studies, we observed that we live in a universe that is expanding, with galaxies increasing their distances from each other, and we were able to explain what we could observe using scientific theory. While we can never see the start of the universe, we can trace back what we can observe using the laws of physics to form a theory of how things evolved. And that is how we reached the current theoretical timeline for the universe and kind of reached consensus on the Big Bang Theory as the leading theory for how it all began. And that, in a nutshell, is where we are today.